The piece of wire shown in the picture is forming a closed loop and it has some current in it. The current is capital I, and we'd like to find the net magnetic field at point P. We can analyze this piece of wire by dividing it into 4 segments, the 2 circular segments that I labeled as segments 2 and 4, and the 2 straight segments that I labeled as segments 1 and 3. So the net magnetic field will be equal to the sum of the magnetic fields created by each of these segments. So let's see which formulas we can use to determine the magnetic field created by each segment. For the circular segments, let's use the formula for magnetic field at the center of a circular loop. The formula is mu0 I divided by 2 times R, I being the current in the loop, R being the radius of the loop. Now this is for a complete circle. In this case, segments 2 and 4 are circular segments, so they're not complete circles. Because the angle is 120 degrees, each of these segments is 1/3 of a full circle. So in our formula, we will multiply this expression by 1/3. On the other hand, the 2 straight segments, 1 and 3, directly point towards point P. Therefore, the magnetic field created by these segments at point P is equal to 0. So let's set B1 and B3 equal to 0. Next, let's determine the magnetic field vectors B2 and B4. For the magnitudes, we will use this formula as I described earlier. And for the directions, we will use the right-hand rule. So let's determine the direction of each magnetic field vector. Let's start with segment 2. The current in segment 2 is in the counterclockwise direction. Curl the fingers of your right hand in the counterclockwise direction. Your thumb is pointing towards you out of the page. And based on the coordinate frame that I have in the picture, that's the positive z direction. So vector B2 points in the positive z direction. Segment 4, on the other hand, has current flowing in the clockwise direction. Curl your fingers in the clockwise direction. Your thumb is pointing into the page, away from you. And based on my coordinate frame, that is the negative z direction. So vector B4 points in the negative z direction. Here I have applied the formula to each segment. Again, I'm multiplying by 1/3 because each segment is 1/3 of a full circle. For segment 2, the current is I and the radius is 3 times d, so this is 3 times d all the way from point P to point B. That's why I have 3 times d right here. And that's the positive z direction, so I have plus the magnitude times k hat. And then for segment 4, I have a negative sign because magnetic field from segment 4 points in the negative z direction. Again, I have a factor of 1/3. The current is again equal to I, and the radius of segment 4 is 2 times d. That's the distance between point P and point A. We find the common denominator and then subtract the second term from the first one. And our final result for the net magnetic field at point P is negative mu0 I divided by 36d k hat. So the net magnetic field vector points in the negative z direction, in other words, into the page.